Hello and welcome to Algebra 2, Chapter 9.2, and today we're going to be discussing graphing simple rational functions. And so keeping with that word rational, that these are going to be functions that look like a fraction. So a rational function is in the form p of x over q of x, where both p of x and q of x are polynomials. So we might be looking at something. You could have x cubed plus 2x squared plus 3x minus 7, because that's a polynomial, over maybe we have another polynomial like 3x squared minus 6. Okay, so that's the function, their form they're going to look at. Now we're going to start out with the most basic ones, and these are just going to look like 1 over x, because 1 itself is a polynomial and so is x. So if we just graph y equals 1 over x, we get a graph that looks like this. So you can see the graph in the red here. And this particular graph is called a hyperbola, or you could just call it a rational function graph. These have two asymptotes. For everything we just did in Chapter 8 with exponential functions and log functions all had one asymptote. So we have a horizontal asymptote here, and that equation would be at y equals 0. Okay, remember that's a line. And we also have a horizontal let's do a vertical asymptote here, and that equation would be x equals 0. Okay, so your domain and your range, your function itself is going to go left and right forever, except it's not defined when x is 0. So we would say it's all real numbers except 0. And similarly with your range, it goes up and down forever, except it's not defined when y is 0. So all reals except 0. And the reason it's except 0 really stems from the fact that you are dividing by a 0, and so x can't be 0. And then there's nothing that 1 divided by any non-zero number will always be a non-zero number, so thus y can't be 0. Okay. These two parts are called the branches, and they're symmetric. So for every xy, there's a negative x, negative y. So if this right here happens to be 1, 1, this over here is negative 1, negative 1. So what I just showed you would be called your parent graph, okay, if we had just 1 over x. But then these can shift, just like we've shifted everything else. And so your asymptotes are always going to start on your axes, and then your asymptotes also shift depending on your graph shifting. And so the h, always with the x, is what shifts you left and right. And remember, that's the one it's the opposite sign, because the minus sign is a part of the function. And then the plus k at the end is what shifts you up and down. Okay? And then a is going to do some expanding, condensing, in the fact that that's what stretches you. And so that will change your numbers a little bit. And that can also make you open upside down. And to open upside down just means they're both going to switch places. So with a positive a, we're going to look like something over here and over here. But then with a negative a, so that's the bottom one flipping up, and here's the top one flipping down. Okay. So to graph, you are going to first draw in your asymptotes, and then we're just going to use a table to find a few points. Okay, so asymptotes starting at 0, 0, and I know on the last slide, I don't think I mentioned it much, but your asymptotes, your vertical asymptote is at x equals h, and your horizontal asymptote is at y equals k. And you can remember those if you want to, or you can just remember the fact that this right here moves you which way? Moves you right 1. So then my asymptote moves right 1. So there's my vertical asymptote. That is at x equals 1. And then your horizontal asymptote gets moved up 2. So then here's my horizontal asymptote, and that happens to be y equals 2. Okay, and so from here we want to graph it. And so you know that one part is to the right of that vertical asymptote, and one part's to the left. And you should kind of know that we're looking at this one over here being on top and then your one over here being on the bottom because 3 is positive. But what I'm going to do is I'm just going to make a table. And I can't put in 1, so I'm going to start by putting in 2. So I'm going to put in 2 for x, so 2 minus 1 is 1, 3 divided by 1 is 3, plus 2 is 5. So I get a point at 2, 5. And then I would do 3. And at 3, I'm at 3.5. And probably do 4. And at 4, I'm at 3. And so this is going to come down this asymptote, turn, and come this way. And it's important to know where those asymptotes are because you can't cross them. Okay? So there would be one of my branches, and then I know the other branch has to be to the left of that asymptote, so we'd actually come and start at 0. And if you plug in 0, you get -1. Okay, so notice that's on the left side of that vertical asymptote. We plug in -1 and work that out. We get a half. So at -1, we're at a half. And then at -2, we are at 1. So this one is going to come in along this asymptote, turn, and go down along the other one. And there's your graph of your rational function. All right, so let's look at another one. Okay, so just concentrating at the beginning on your asymptotes, the vertical asymptote shifts to the right 4. And I know that's the vertical one because it's shifting to the right. Okay, my horizontal one shifts up 3. So there's my asymptotes, and so I know I have a part over here and I have a part over here. Now that negative at the top, we're going to see that it's going to switch it, it's going to reflect it over the x-axis. But if we just start, so since we went to 4, let's just start at 5. And if I plug in 5, I'm going to get 2. Okay, so that's going to tell me I'm going to be below my horizontal asymptote. We're going to do 6, and we get 2.5. And you might go through these. I've worked them out ahead of time, but you might go through them and make sure that you get them. Oh, that's supposed to be a 2/3, not a 3/3. So then at 6, we're at 2.5. At 7, we're at 2 2/3. And if you're ever curious, you could always do 4.5. You need to do as many points that you accurately have this graph. And so 4.5, we're at 1. And so then I can see that this is going to come up this way, turn, and go that way. Okay. And then for the other branch, I'm going to start on the left side of 4. So I'm going to start with 3. And at 3, we're at 4. And we'll do 2, and at 2 we're at 3.5, and at 1 we're at 3 1/3. So at 3 we're at 4. 1, 2, 3, 4. Right, and I'm never going to get below 3, so here we're going to come in along this asymptote and come up here. Now, I might have skipped this on the last one, but it does ask for domain and range. So domain is all real numbers except what? Except 4, because that's where my asymptote is. The range is all real numbers except 3, because that's where that asymptote is. So the next thing is to look at a rational function in a little bit different of a form. And so this one is ax plus b over cx plus d. And because you can never divide by 0, if we set the bottom equal to 0, that's going to give us what x can't equal, which is a vertical asymptote. And we happen to find our horizontal asymptote by taking the leading coefficients off the top and the bottom. So make sure you have that written down and let's see if we can utilize it. Okay, so we're going to graph this, and so the first thing I would find are my two asymptotes. So let's just start with our horizontal one. And you just wrote down that it's A over C, where in this case A is 1 and C is 3, because it's going to be this part right there. All right, so we're going to have a horizontal asymptote at a third. Tell you what, well, we'll draw it in. We'll see how close I can get to a third. So it's down here. It's at a third, so we came a third up. And then we're going to have a vertical asymptote. And you really need to find these first because it's going to help you in where are you drawing this graph along. All right, so we're just going to take the bottom and set it equal to 0. And this will tell us what the bottom what x cannot be equal to. So when x is -1, the bottom equals 0, and I can't have the bottom equaling 0, and so that means I have to have an asymptote at x equals -1, which would be right here. So after that, you're going to do the same thing you did before in terms of points. We know there has to be one to the right of that asymptote, one to the left. So if we start to the right, I would start with 0. And we're going to get -2/3. Okay, so I'm going to be below it. And we go to 1, we're going to get -1/6. And if we go to 2, we're actually going to get 0 because that makes the top be 0. The top can be 0. 0 divided by anything is 0, so that turns this way. And then we need to come to the left side of the asymptote. So if we start at -2, we are at +4/3, or 1 1/3. -3 is at +5/6, so closer yet to 1. And -4 is at 2/3. Actually, sorry, 5/6 I put on the wrong side, didn't I? That would be less than 1. See if I can fit them all on the other side here. 5/6, then 2/3. It's because I didn't really get my 1/3 in the right place. That's okay. There we go. And so domain and range here. Domain, all reals, we go left and right forever, except, where do we not touch? -1. And our range, we're going to go up and down forever, except not at 1/3. All right, that's what I have for you for 9-2. Let me know if you have any questions, and if not, I will see you in class next time. Have a great day.